All right, so today we're talking about arithmetic sequences, so I need to know what's a sequence. Now, if I'm looking at this definition, does it look familiar to anything? Like maybe a couple days ago, yesterday? Sequence is an ordered, we've seen that before, set of elements that follows a pattern. So what does this remind you of? Do you guys remember what sounds like that definition? A set of ordered pairs, which would be relation. So are sequences and relation the same exact thing? No. But they're similar because they have ordered parts, they're dealing with sets, and we're also dealing with elements. Okay, I'm going to move on from here soon. Okay, you need to get these two sequences. We're going to be talking about both, mainly the second one. Have you guys heard of that word finite and infinite? How many of you heard of the word infinite? What does infinite mean? Now that we've talked about it many, many, many times. Why?
It goes like on and on and on forever.
Yeah, it goes on forever. It doesn't have an end. Okay? What do you think finite means? What do you think finite means, sir?
It has an end.
It has an end. And so you guys can see it from the definition. A finite sequence has a first and last term. It has a beginning and it has an end. What about infinite? It does not have a last term. Did I say anything about the first term? No, it can have a first term, but it can also not have a first term. You're like, how is that possible? The sequence started from infinity past and goes into infinity positive or future. But don't get too bogged down with that. I think of finite actually a lot when I think about my abilities, my understanding, my knowledge. As Mr. A has gone these 32 years of his life, he's gained some knowledge. Not as much as I wish I received, but I have a certain amount of knowledge. When I get to be whatever age God wants me here on this earth, I will have a set amount of knowledge. But how can you describe that knowledge? Finite. That means it has a beginning and it has an end. But I think of some guys like Albert Einstein. Is his knowledge finite? What do you think? Finite. Sorry, I don't know what happened. But is his knowledge for Albert Einstein, is it finite? It is. It had a beginning like mine. Maybe he went really fast after that, but it had an ending and maybe it was way out here. Maybe it was way out here, but it had a beginning and an end. Whose knowledge is not finite?
Yours and mine.
Okay. Sorry, I just explained that mine is finite and Albert Einstein's is finite. So, yeah, God's knowledge is infinite. And that to me, guys, even saying that, I don't understand that, which shows and we would say the finitude of my knowledge. I do not have infinite knowledge. I can't even understand this kind of knowledge. Mike.
Why don't you pronounce it infinite?
Yeah, actually someone in class said it. They're like, infinite. And they're like, it's just, it's kind of like Spanish, depending on how long the word is. Either you put an accent or you don't put an accent, depending on the meaning and all that. So yeah, infinite. And I don't know the full etymology we would have to call this. I don't know. But yeah, infinite. So don't say infinite. I don't want you guys to be called on. Who taught you that? It was my math teacher. Oh, no. I don't take credit for that. Okay. How do you know that this sequence is finite? Can anyone tell me how you know it's finite? Yep.
Because it does not have the dot like the infinite.
It has a starting point and an end, a beginning and an end. First term and the last term. What about this sequence right here? There's a first term. Wait, isn't that the last term? Okay, what are these three dots called? Ellipses. And when you have ellipses, what do you think? It keeps going on and on and on and on. So it doesn't have an end. And I'm not going to show them all because I don't have enough room, but you get the point. When you see ellipses, we're dealing with what kind of sequence? Infinite. Okay. Let's look at the sequence. What is that? 16, 48, 80, 112. Finite or infinite? Finite, because it doesn't have the ellipses, if you want to think that way. Notice I have these arrows pointing to each one of these numbers. What are each one of these numbers called? Terms. So if they're called terms, we need to be able to identify which term are you talking about. Okay. Maybe you're looking at the right side of the board thinking, what is he trying to say here? Okay. I pronounce this, or I say this as A sub 1. Why do I call it A sub 1?
It's like at the bottom.
It's below A, like it's beneath A. You know, if I had an exponent, you know, exponents go above. I technically could say A super 1, because super means above. So we don't say that with exponents, but because we have exponential notation. But I would read this A sub 1. Okay, everyone say that with me. A sub 1. What do you think A sub 1 means? Like, what am I asking for? What equals? I don't even know what it is. It's the first term. So what's the first term? 16 is A sub 1 in this sequence. Is A sub 1 always 16? No, it depends on the sequence and it depends on the terms, all that. How would I read this right here? Anyone? Can anyone say? Oh, Nick? A sub 2. And what is A sub 2 in this sequence? Yes?
48.
48. And basically I'm asking, what's the second term? Okay, A sub 3. What's the third term in my sequence? Yes, Murphy? 80. Great. Now I have, okay. I don't know what that means, but can someone just read it for me? How do I read this? Peter? A sub n. Good. A sub n. A sub n. What does n stand for? This is asking you for any, it depends on what I ask you for, where you would place n. It really means the nth term. You're like, nth term. Okay, if this sequence were, don't write this in, if the sequence were infinite, I could ask you, and I will ask you for the 10th term. Do I have the 10th term up there? No, you have to figure it out. And sometimes I'll ask you for the 50th term or the 211th term. So what would I replace n with? 50 or 10 or what did I say, 211th? I don't know. You just replace it with that. So here's what I mean. What's the fourth term? Yeah, if I was looking for the fourth term, I would say A sub 4, and then I put 112. This stands for any of them based on whatever I want to look for in this problem. Okay. Infinite or finite? Infinite. Do I have all the terms up there? No. In fact, you see the one is underlined, but there's nothing above it. What do you think I want you to find? Okay. This is what you need to do either mentally or writing it on your paper. Okay, this is a sequence because it has that dot, dot, dot. It follows a pattern. But what I have to do, and this is what a lot of you do mentally, and some of you might need to write down, I need to find out what is that pattern. Like, how are they related? How do I get that fifth term? Well, what I would do is I would do 48 minus 16. What's that? 32? Good. 48 minus 16 is 32. I just subtracted the second term and the first term right there. I'm going to subtract the third and the second, which is 80 minus 48. And that's, it's 32 again, because you had to borrow. So 32. And then I'm going to do 112 minus 48. And what would that get? Minus 80. And what would that get me? Oh, look at that. Is there a pattern? Yes. Is there something that links those numbers together? Yes. Okay, here's what I want you to get because this is going to be super important. Do you notice when I subtract these two, or these two, or these two, I get the same number? Okay, what is this number in a subtraction problem called? This vocab time. What is this number right here called in a subtraction problem? The answer to a subtraction problem is called the difference. It's the difference, right? When I say find the difference, what operation comes to mind? Subtraction. So what's the difference here? What's the difference? What's the difference? Okay, do we have a common difference? The common, I was almost going to spell that wrong. The common difference is labeled D. The common difference is labeled D. And what is the common difference in this problem? It's 32. The common difference is 32. So that's something to know. And you're like, why? Well, you're going to see why it will help us not only on these problems, but more for the next kind of problems we're going to get soon. And just a review question. What's the first term? What's the fifth term? Yes, ma'am? 144. Wait. How'd you get that? Emma Grace? That's it, but how?
I added 12 and 32.
Okay, you added 32 with that 112. And, 144. Do you know what you did? You added the common difference. That's how you get the next one. Can anyone give me the seventh term? You may begin. Are you guessing or?
308?
It's 208.
Okay, how did you? Who got it? How'd you get it?
Well, either you can just do the hard way and add it
Twice 32.
twice, or you can say that you're trying to get like 2 terms more than the fourth, or 2 terms more than the fifth. So you can like multiply 32 and times 2 and add that.
Gotcha. So, 208. Yeah, we're at 64. Good. I think that's what you were saying, Jensen.
What you could do is, whatever number you're on, like around 112, you do 18 minus whatever the number is, and you get 4, and then you multiply 4 by 32.
Okay, actually, Jensen, I think what you're saying is, I'm not totally sure exactly, I didn't follow it, but I think what you're saying is leading to what we're going to do. Okay, guys, in your head, find the 20th term. Sorry, do it on paper. You can do it on paper. Sorry.
20th term?
20th. Not the 19th, the 20th. How much time do you need? Because I got to get going. Okay, keep going.
Yeah, how do you get there?
One way to get it is to do, okay, you got the 144, you add 32, add 32, add 32, add 32, add 32, just as many times as you need. But if you're off a little bit, that's not the term. You got it wrong. So there's got to be an easier way. I hope there is. Yep.
I did the a sub 5, which is 144. I multiplied that by 4. Could you do that? Because 5. Wait, that doesn't make sense.
It's not illogical. No, it's not illogical. It's just we're gonna see if there's a better way, because that's kind of like, I hope it's that, right? Okay. Yes, Davis, you're getting closer. Okay, save your answer because I don't want it. I don't even know it. We'll figure it out later. Save your answer. Do you have it? You have an answer, Emma? Emma Grace? Okay, just save it. We'll go through it. We'll make sure every one of you gets it. Okay, I haven't even talked about what an arithmetic sequence is. I haven't even brought arithmetic sequence up. We've just been looking at sequences. And you need to know that each term after the first is found by adding the common difference to the previous term. What? It's what we did on the last problem. Okay, there are 2 key words I want you to get in this definition. The word adding and the phrase common difference, or the term common difference. Adding, common difference. Difference, adding, what? Anyone a little bit, maybe you're still writing, so you're like, I don't know what you're saying, Mr. I'm just writing this down. But when you look at it, at my underlined words, is there any conflict at all?
Yes, because adding does not equal difference.
Yeah, adding is adding, and difference is subtracting. And do those two ever meet together?
Yes.
They meet together all the time. In fact, in sequences, they do meet together. We're going to find the common differences of sequences, and then that common difference can be added to get a next term, or 2 terms, or 3 terms, or 4 terms after that. Because adding and subtracting are related. And here's another way why. Yes, ma'am.
Why do you keep putting the D?
Because whenever you see the letter D in these problems, you think common difference. Yeah, just so you know, D refers to common difference. Why does that matter? I think you guys are good on that. Because I get sequences here. And before I find... Sorry? Yeah, we'll get to that once we get to the formula. So we're not there yet. This is example 1 right here. 2, 3, 5, 8, ... I want to know if it's if it's an arithmetic sequence. So that's what I'm asking for. If it's an arithmetic sequence, get me the next 4 terms. Okay, how do I determine that? Well, I'm going to do 3 minus 2. 3 minus 2 is what? 1. Then I'm going to do 5 minus 3. What's that? Oh, cool. What's 8 minus 5? Nice. Do I have a common difference? No. This is a difference. This is a difference. That is a difference. Are they the same? No. So you know what I know about this sequence? It is not arithmetic. It is not arithmetic. Yeah, great question. But Mr. A, isn't that a pattern? And the answer to that is yes. And it is a sequence. But is it an arithmetic sequence? Do you add a common difference each time? No, it's a different type of sequence. It is a sequence. It is a pattern. You can find the next 4. But here's what I'm trying to tell you. On all the problems on your homework, are you going to have to find the next 4? No, because if it's not an arithmetic, do you have to find the next 4? No. If it is an arithmetic, yes, give me the next 4. So I can save you some time, and trust me, they're not that easy. But make sure you know if it's arithmetic or not. All right, let's look at this sequence right here. 42, 19, negative 4, negative 27. And I want to know if it's an arithmetic sequence. If it is, then I want to make sure that I can find the next 4 terms. Okay, this is what I'm going to do. 19 minus 42. So when I do 19 minus 42, do I just like 19 minus 42? Is that what I do? No, don't do that. You do 42 minus 19, and what's my answer going to be? Negative. Okay, so here are, if you need to, you borrow. Negative 23. So the common difference, or sorry, not the common difference because I don't know if it's common, but it's negative 23. Do you understand how I got that? Okay, now what I'm going to do is I'm going to do negative 4 minus 19. I do negative 4 minus 19. What does that get me? Oh, that seems pretty common, but yeah, negative 27. Listen carefully. Negative 27 minus negative 4. Stay, change, opposite. What does that give me?
Negative 23.
Because if you subtract these, if you did something else, you get like negative 31 or negative, negative 31 I think would be your next one. That's not an arithmetic sequence, but you did it wrong. That's what happened. Is there a common difference?
Yes.
What is the D value? Good. Negative 23.
So we put that in.
Yeah, well, if they ask you what's the common difference, there you go. But how do I find the next term then? I'm going to take negative 27 and not subtract, but add negative 23. What's negative 27 plus negative 23? Negative 50. So that's the next term up here. How do I find the next term after that? I take negative 50 and I add negative 23. What is that?
Negative 73.
Negative 73. And go ahead and find the next 2. Murphy, did you have a question?
Oh, I was just saying, what if it was like negative 23, negative
Something else? Mm-hmm. It would not be an arithmetic sequence, but be careful of that because if 2 of them are the same, the third one should be the same, but I can't say that for all sequences.
So you might have messed it up.
Either we wrote it wrong, or I'm trying to trick you. And I do both of those, don't I? I write things wrong, and I try to trick you sometimes. Yes, ma'am.
Would it be a common difference if it had like negative 23, negative 15, negative 23, negative 50? So it can't.
It has to be the same exact number. Yep. That's for arithmetic sequences. Guess what we're looking at tomorrow?
Non-arithmetic.
Specifically, what kind? You can look.
Specifically defined as geometric.
Geometric sequences. All right. So today, arithmetic, and then tomorrow, geometric. What are the next two? What's the, how about this? 1, 2, 3, 4, 5, 6. What's a sub 7, I believe, if I'm correct here? What's a sub 7? 96. And then what's a sub 8? Sorry, I heard two things there.
119.
100, yeah, good. 119. Okay. All right, so how many of you got negative 50, negative 73, negative 96, and negative 119? Yes, ma'am. Oh, while she's asking her questions, just get me the 30th. Don't do it. Yeah, that's mean. Not yet. Are you okay, sir?
Yeah, I read it.
All right. I'm not going to ask you for the 30th because you don't have the tools to make it easier. It just becomes a tedious process. You're just going to be...
No, it's not.
Good. Try it on this. Give me the next 4 after determining if it's arithmetic or not. So is it arithmetic? I don't know. If it is, next 4. If it's not, you're done. I'm going to do 3 halves minus 1 half. Do we have common denominators? Which is nice. What's 3 minus 1? 2. And then I get 2 over 2, which is really just 1. Okay, then I'm going to do 5 halves minus 3 halves. And what does that give me? 2 over 2, which is just 1. And then I do 7 halves minus 5 halves. Which equals 1. Do we have a common difference? Yes, the common difference is 1. But I need the next 4. I need the next 4 terms. So what do? I take the 7 halves and I add 1. And how would you add it though? Good, 2 over 2. So you can go back and forth. And what do you get?
9 halves.
All right, and then hopefully you can see a sequence, and I'm okay with these improper fractions. So next 3 then. Well, because I gave you the first one, you give me 3 more.
Yeah, is this what we're doing for all?
No.
What? We already done.
We haven't even gotten to the coolest part yet. It's not even the coolest part. This is like, this, guys, is we can go over in 7th grade and even 6th grade. Sorry? All right, how many of you got the next, I guess the next 4. This is the next one. All right, Peter, what's the next one?
I got
11 over 2. Next one?
13.
And last one?
15 over 3.
Okay. So 9 halves, 11 halves, 13 halves, 15 halves. Okay, good. I need you to get this down. There's a formula you can use that can give you any term of any arithmetic sequence. Any term. If I wanted the 1000th term, you could do it. If I wanted the 51st term, you could do it there. As long as we're talking about arithmetic, we could do it here. So I think someone gave what it almost would have been like, but you got to make sure you put a component that would cause it to be correct. Mm-hmm.
I will let you can do it defining the issue, whatever. So.
Go ahead.
One.
Okay, here is the formula right here. Here's a formula, and here's my key. So like, what does a sub n mean? It's the nth term. Nth term, what is the nth term? I don't know yet either. I'll show you what it means in just a moment. What does a sub 1 though mean? First term, and we looked at that previously. This is the first term of the sequence. What does D stand for? The common difference. So we have looked at D and A sub 1. A sub n we kind of looked at, but it wasn't super clear. So here's what I'm telling you about A sub n. If you're asked, what's the 51st term? You're looking for A sub 51, and that's which term? 51st term. So if I say, give me the 51st term of that sequence, what should replace n here? 51st, 51 right here. What should replace n here? 51. That's what you replace those numbers, because this can be any number. I don't know what the problem's going to ask you. Give me the 10th term. What would you replace n with? 10. N with 10. Okay, and then what's A sub 1 again? The first term of the sequence. What's D again? Yeah, don't be tricked by the key that is right there underneath that formula.
Like the other one, and I almost got it, just the -1.
Yes, because you have to consider that you're finding -1 because you already got the first term added with that part.
Can you tell us the answer of that one?
We will. We'll get to that. Yep. That's like our final problem. Okay, find A sub 16. What is that talking about? Find the 16th term. So what terms do I have here? First, second, third, and fourth. I want the 16th. Okay. How do I find that? And actually, it should be like this. How do I find the common difference, which is really what I'm looking for? Well, shouldn't I do 2/3 minus 1? And you're like, wait, isn't 1 also known as 3/3? So what's 2/3 minus 3/3? -1/3. All right? What is 1/3 minus 2/3? -1/3. What is 0 minus 1/3? -1/3. Do we have a common difference? We do. It is -1/3. So do common differences have to be positive? Do they have to be negative? No, they're one or the other. Sorry?
So for the A sub n,
Mhm.
put 16.
Yeah, I put it up there so we have the formula. So here's what I would do. A sub, which one are we looking for? The 16th one. What's A sub 1 in my sequence? 1. What's n? 16 minus 1. What's D? -1/3. You're just filling in the parts that you know. Yes, sir?
Will we ever have irrational numbers on our assignments?
Not today, no. And yes, later on, but not today. Will you ever have algebraic expressions?
Yes.
Today? Yes. Yeah, but we won't. I'll tell you what I'm doing with that. All right, I want to figure out what this is worth right here. What would I do first?
You would do the parentheses.
Yeah, so I'm going to get 1 plus, what's 16 minus 1? 15. And still times -1/3. Okay, what would I do next? I would multiply these two, right? Because the parentheses are already simplified. So I'm going to get, nice. What do I get? I get plus -5 with the 1. What's 1 plus -5? What is the 16th term in this sequence? -4. So the first half of your homework, guys, find the next 4 terms. So use the other method. Don't use this. This can take a long time if you're doing it 4 times. If they say to find like the 20th or the 10th or the 50th, I'm using this method because I don't want to count all that way and get really, really close, but then get it wrong. Go ahead and find. No. Find the, what's my favorite number? 71st? Find the 71st term. Yeah. Yeah. Today it is. It just came to mind. That's how much I like it. I do not remember. It might have been 8th. It might have been 10th. I think it might have been like 50, but I want 71. I don't know. Okay, so first I'm going to find the common. I'm going to do -5 minus 2, which is -7. -12 minus -5, -7. And you're like, how is that negative 7? Say change opposite. And then negative 19 minus negative 12 is still going to be negative 7. What's the common difference? Negative 7. Which term do I want? 71st. Why would I do that? I don't know. What's the first term? 2 plus 71 minus 1 times negative 7. It's really not that. What's 71 minus 1? 70. What's 70 times negative 7? Negative 490. What's 2 plus negative 490? Negative 488. What's the 71st term of the sequence? Negative 488. Would you rather list them out to get there?
Yes.
How about this? You're allowed to do that. You're allowed to do that. I just want to see them all. If you're going to use that method, I want to see them all. Because, all right. Let's go back to that last problem. What's the problem that we did that we didn't get the 20th? 20th term? Give me the sequence first.
It's 42, 19. No,
I think it was the first problem, wasn't it?
Yeah, 16, 48, 80, 112.
16, 48, 80, 112. And what did I ask for? 20th?
32.
I think it was the 20th. 20th. Find the 20th term. Go ahead and find it. I don't know what it is. I haven't figured it out yet. We're finding the 20th. And the common difference was 32. Yeah, okay, the common difference is 32. That's right there. We're looking for the 20th, so that's where we get those 20s. And the first term was 16. Why did I pick this one? Yeah, you actually have to, actually multiply. Actually, oh my goodness. It's actually distributive property if you want to make life easier, but that's up to you. So 32 times 20 is 640 minus 32, which would be 80608 plus 16, 14, 12, 6. Sorry, I said that wrong.
Right. If there's proof on the view.
I will test it for time, test it for your prints, and see if it's really yours.
Okay. I will.
John's up for it. Well, sorry, did you guys get, or who got their answer already? Who has the 20th term? What'd you guys get?
600.
All right, 624. Do you have to list them out? No. You can use this formula, and that can help you out, and you can get 624. Okay. And Mr. A did it differently. He did not do it. Yeah, I did 640 minus 32 because I did this. I don't like 19 times 32. I said 32 times 20 because that's easy to do. What's that? 640. But I added an extra 32, so I subtracted. Then I add the 16. Boom, got it. That's distributive property, guys. Mr. A is not good at quick mental math, but distributive property really helps me out. It's like taking vitamins. Yeah, I was going to say something else. It's like taking vitamins. Okay, your homework. I think I told the last class something else. Is 2 to 12 even? Do not worry about number 4 because it is a bonus question. So I'll give a little help on number 4, but you don't have to do it. But if you do it and you get it right, you get bonus points on that. But you are doing 2 to 12 even. And I hope you have a great, so have a great Thursday. Yeah.